Yes, sir.
Right. So because answer is yes, because x square minus 5x plus 6 is x minus 2 into x minus 3. Am I right? So therefore this is my qx is equal to hx times px. What is hx in this case? Hx is x minus 3. So there is another polynomial which is a factor of qx. So note that if px divides qx, then we write it as, if px divides qx, then we write it as px vertical line qx, right? Not slanting line, not horizontal lines. It is a clearly vertical line, right? So px divides qx. What does it mean? So therefore, in this case, x minus 2 divides x square minus 5x plus 6, right? Is it true? X minus 2 divides x square minus 5x plus 6. Thus,
Yes.
so
Can you explain?
x minus 2 divides x square minus 5x plus 6. Is it true?
Yes.
Who asked the question? क्वेश्चन कोणी
Yes,
विचारला?
sir.
हा, तुझं नाव काय?
Prajakta.
हा. So x minus 2 divides x square minus 5x plus 6. Is it correct?
Yes, sir.
हा. Now this is a notation. Notation means the symbol ki if px divides qx, then we write it as, see,
Mug,
if
sir.
if a is greater than b, then how do we write this? A is greater than b. This is a symbol to say that ki a is greater than b. Similarly, P divides Q, that means Px vertical line Qx. What is the meaning of this? Px divides Qx. That means x minus 2 divides x square minus 5x plus 6. Right.
Yes, sir.
So 2 divides 6. What does it mean? 2 divides 6. That means 6 is equal to 2 times 3. So that means P divides Qx means, so what is the meaning of this symbol? So P vertical line Q, that means P divides Q. Px divides qx means what? Px divides qx means what? There exists another polynomial hx in Rx such that qx is equal to hx times. That means px is a factor of q,
Yes.
therefore p divides q. There is another factor. So this is what the meaning is. So if fx is equal to x minus 1 and gx is equal to x cube minus 3x square plus 3x plus 1, does fx divides gx? Is it true? You check this.
Yes.
Yes, right? Because why? Because gx is equal to fx into some hx. What is gx? X cube minus 3x square plus 3x minus 1. Okay, I should say minus 1 here. So minus 1 here. So therefore it is x minus 1 cube. And is it same as x minus 1 into some another factor? What is that another factor? X square
X minus 1.
minus x plus 1. Is it correct? Right? This is gx, this is fx, and this is hx. So gx is equal to fx into hx. for some another polynomial. So this is another factor, this is one factor, and fx. Right, can I say that x square minus x plus 1 divides gx? Can I say this?
Yes, sir.
Yes. When I say that 2 divides 6, that means 6 is equal to 2 times 3. That means say by same logic I can
Sir,
say that 2 divides.
the excuse me, sir.
Yes.
hx must be x square minus 2x, na?
Uh,
x square minus 2x plus 1.
Yes.
no. Why?
X
Is
minus
it
1 whole square.
x square plus x plus 1? I think it is correct. Not 2.
No, sir. Minus 2x plus.
What is a minus b cube? A minus b into a square plus ab plus b square. Is it true? This identity.
Yes, sir.
And what is b here? Minus b is 1 in this case, and a is x. So this identity, if this identity is true, then this is true.
Excuse me, sir.
Yes.
Sir, isn't this the identity of a cube minus b cube?
Uh,
Yes, sir.
oh, it is a cube minus b cube. So this is not true. Okay, okay. I am sorry. I got confused with this. Okay. What is another factor? Okay, this is, yeah, you are right. So what is the identity? It is actually x minus 1 square, another factor. That means x minus 1, x square minus 2x plus 1. Correct. This is hx. Then x square minus 2x plus 1 divides gx. Right? So this is true. Right? Am I right?
Yes, sir.
Okay, now it is correct. So note that for fx gx in zx, we say that fx divides gx in zx if division takes place in integers, or here it is polynomials over integers. So a divides b means what? In integers there exists another integer c, right? So that b is equal to ac. That means this divides, a divides b in integers, so everything is integer. Factor, another factor or quotient is integer. When I say that fx divides gx in zx, that means I should get there exists hx in same set such that gx is equal to hx into fx. This is by definition, correct? Am I right? Right?
Sir,
Yes.
we can say that in this case, if fx divides gx such that gx equals to hx into fx, also hx divides gx.
Yeah, that is true. Then we can say that hx divides gx. This is true clearly, no problem. But there is another factor. That is the main point. Why 2 divides 10? Why 2 divides 10? Because there is 5. 10 is equal to 2 into 5. There is another factor which is 5. Ultimately 5 also divides 10 because there is another factor 2. Right?
Yes, sir.
Now, if f of x is equal to x square minus 2, x square, what I want here. Okay, so f of x is equal to x square minus 2. and gx is equal to x minus root 2. Now questions I can ask is gx belongs to zx?
No, sir.
Is gx belongs to qx? Is gx belongs to rx? Right? Is it true that gx divides fx in qx? Next question I would like to ask is gx divides fx in rx? Questions are clear. Is gx in zx? Is gx in
No,
zx?
sir.
No, because coefficients are not integers. Coefficient is root 2. One coefficient is root 2, which is not integer. Right? Is gx in qx?
No.
No,
No,
sir.
because coefficient is root 2 and 1, but root 2 is not rational. So if polynomial is in qx, all coefficients are rational. Is gx in rx?
Yes, sir.
Yes, sir. Yes, sir.
Yes, root 2 is a real number. Is gx divides fx in qx?
No. No,
Right.
sir.
So if I write fx is equal to x square minus 2, so it is x minus root 2, x plus root 2. And what are the factors? Factors are not rational from factors are not in qx. So it is also no. Is x divides fx in rx?
Yes, sir. Yes.
Right, because here this is gx into hx. And what is hx? X plus root 2. And this is in rx. This is in rx. Right, so both factors are in Rx. In Rx, it is possible to divide this polynomial by x minus root 2. So here answer is yes. Right, so how thing changes? In which domain you are going to divide? In which? Now this question is exactly similar to does 2 divides 5 in Z? Is it true? Is does 2 divide 5
No.
in Z? No.
No.
Does 2 divides 5 in R in Q? Does 2 divide 5 in?
Yes.
So 2 divides 5 in Q by definition of divisibility if there exists some C in Q such that if 5 is equal to 2 times some C. Is it possible to write 5 as 2 times some element of Q? 2 into
Yes.
5 by 2.
Yes,
2
This
sir.
is
into
like
1 by 5.
2 into 5 by 2. This is 2 and this is C and this C is in Q. It is possible, right? But 2 does not divide 5 in integers, but 2 divides 5 in rationals. And why this is possible? Because multiplicative inverse of 2 exists in rationals. That is the thing here actually. And therefore in rational numbers or real numbers, every non-zero real number divides any other number, right? In Q or R, if A is not equal to 0 and B is in Q or R, A divides B. Right, so every non-zero element divides any other element in rational numbers or real numbers, but it is not in case of integers, and therefore the divisibility is not very interesting to study in real numbers or rational numbers, and where divisibility is important to study in integers, right? Because there are situations which are non-trivial situations. That means there are elements which do not divide other element. If everything is nice, ki every element divides any other element, then there is no charm or nothing to study, right? Correct. So divisibility is always studied about integers, not about real numbers or rational numbers. You see any number theory book, divisibility is studied about integers only, and therefore concept of divisibility, concept of GCD, concept of LCM, greatest common divisor, or everything is about integers, because there are something non-trivial numbers. There is something which is possible, right? Therefore, divisibility in which set, that is important. So divisibility means, does the factor exist in that set? So that is important. That is what this says. Ki x square minus 2 is divisible by x minus root 2 in Rx, not in Qx or not in Zx. That point you should note. Important point. Ki divisibility in which set? Yes. Is it clear? So if f of x is equal to 2x minus 4, right? This is a polynomial, and this polynomial is in Zx as well as Qx as well as in Rx, no problem. And Gx is equal to 2, for example, right? Does Gx divides Fx in Zx? What is your answer?
Yes.
Answer is yes, because Fx is equal to 2x minus 4, which is 2 times x minus 2. And therefore, this is a one factor Gx, this is another factor Hx, and is this factor in Zx? Is this factor in Zx?
Yes.
Yes, sir.
Right, certainly. So therefore, we can say that the Gx divides Fx in Zx, because clearly we got two factors of Fx, both are in Zx. Right, therefore answer is S. But if you look at Fx is equal to 2x minus 3, right? So this polynomial is in Zx, this polynomial is in Qx, because coefficients are real numbers. So right, so this polynomial is in Zx, Qx, Rx, whatever you say, and Gx is equal to 2. Is Gx divide Fx in Zx? Does Gx divide Fx in Zx?
No, sir.
No, sir.
No, because if I try to extract the factor 2, 2x minus 3 from Fx, so x minus 3 by 2, then this is in Zx, but this is not in Zx. Right, the second factor is not in Zx, so we cannot have both factors in Zx. Therefore, division is not possible in Zx for by 2. So 2 does not divide this polynomial in Zx. Do you understand the difference now? Do you
Yes, sir.
understand? The second factor is not in Zx because its coefficients are not integers. Right? Now, does Gx divide Fx in Qx? Is it true?
Yes.
Yes.
Because Fx I can always write it as 2x minus 3, which is 2 into x minus 3 by 2. And this is my Gx, this is Hx, and Hx is clearly member of Qx. So both factors exist in rational polynomials. So polynomials with rational coefficients. So this is possible to have factors in Qx. So in this case, answer is yes. In this case, answer is no. Right. So from this example, I think it is clear the thing should be clear. What I mean to say that divides in Zx, divides in Qx, or divides in Rx. Right. So note that if Px in Rx, mostly we'll study polynomial over real coefficients, and then something we'll study about polynomials with rational and integer coefficients, some properties. And Px is suppose non-zero polynomial, then Px is equal to 1 times Px, right? Therefore, can I say that Px divides Px? Can I say that Px divides Px? Yes.
Yes, sir.
Right? So Px divides Px. That is certainly true. Second point, if Px belongs to Px and Qx basically. So if Px and Qx are polynomials, so such that Px divides Qx, then there exists Hx in Rx such that there exists Hx in Rx such that Qx is equal to Hx times Px. Right, this is by divisibility we know, but moreover, if degree of Qx is equal to n, then degree of Hx and degree of Px. What can you say about degrees of these two polynomials, Px and Qx?
Addition
Really
must
Yes,
be n.
anything.
less than or equal to n, not greater than n. Correct? Must be less than. See the previous examples. So 2x minus 3, what is the degree? 1. Right? What is the degree of gx here? 1 factor. What is the degree? 0. What is the degree here? X minus 3 by 1. So both have degree at most n, not greater than. So degree of fx is 1. Then degree of factors of fx is certainly less than or equal to. Why? Because if you multiply these two factors, the degree will be the sum of degrees, and that will be greater than degree of fx. That cannot happen. Therefore, degree of these two factors must be less than or equal to. In fact, what is the one more observation? Moreover, degree of px plus degree of qx must be equal to n. That should happen by the multiplication principle. If you multiply two polynomials, and then what is the product? If you multiply not px, what I say, hx, degree of px plus degree of hx should be n. Why? Because hx into px is qx, and it is degree of qx, and as we discussed yesterday, degree of product is what? Degree of hx into px is degree of hx plus px. Why this is true? By yesterday's discussion, degree of px into hx is degree of px plus degree of hx. But what is hx into px? What is hx into px? Is qx, and
Yes.
therefore degree of qx should be degree of px plus degree of hx. So therefore n is equal to n is the degree of qx. N is equal to degree of px plus degree of hx. That is what the observation you can have. So degree of factors is certainly less than or equal to, right? So 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 let f of x is equal to x square minus 2 and gx is equal to x cube minus 5x square plus 6x plus 7. Thus fx divides gx. So you just think about it, and to understand this divisibility, we'll have some techniques. Smart techniques are there. Smart results are there. We'll discuss those results in the next sessions, so that easily you can predict whether something divides some polynomial divides to another polynomial or not. Right? Okay, so we'll discuss next time. We'll stop here. If you have any difficulty, you can ask.